So you'd expect the best part is no part that the cooling system would be way thinner, way smaller on the Cybercab, but it's not. It's way bigger. And that's not just washer fluid is my working theory.
So then, why did Tesla make this Cybercab's cooling reservoir dramatically bigger? Hola, soy Alejandro Sauquillo y hoy estoy aquí otra vez with Joe Justice. Thank you very much, Joe, because everybody knows you in the Tesla community and in the Agile manufacturing community that you are the worldwide expert in Agile manufacturing. You also run Agile at Tesla, so you worked inside Tesla. You have been consulting the main manufacturing facilities in the world. But we have to remember that you also build car company yourself, so you know how to build cars. And something that many viewers might not know that I got to know lately when you came to Spain is that you have also an EV racing team, Wikispeed team. So you have around 9 Tesla. Is it something like that?
There's 6 racing right now this year, and there's 2 more on order.
Okay, so you really know everything about the product and the manufacturing, both from your experience as a professional of the agile world and the manufacturing world, and also for your passion. So anybody that is watching this, if you want to hire the best person in the world who knows the mass companies, you just have to contact Joe in abi-agile.com, that there is an English button. So let's not forget about it. Okay. So the reason why I contacted you for this interview is like lately has been some pictures of the Cybercab under the hood. There's this video from Joe Tegmeyer that many people might have known where there is the Cybercab under the hood. So do you see it more or less in this picture?
I can see it clearly. Thanks so much. And thanks, Joe Tegmeyer, for posting all this on X.
Okay, so could you tell us what you see in here from your experience that the regular guy won't see?
Well, Joe Tegmeyer has
Yes.
given us an awesome analysis of what the car is looking like. And Alejandro, I think you and I will get into some specifics where maybe I can add some value. But I'd like to start with the setting around the car, which is so unusual. So I'm in Japan right now, and I continue to work with Toyota and the Toyota family of companies, their suppliers and their primary investments. And their R&D centers and their manufacturing sites, one, are totally separate. They're kilometers apart. The same people don't go to the same places. The same custodians don't work in the same places. So if you're involved in design or finance or making decisions, you're not at all related to where things are built or designed. Here you see shipping containers. You see shipping containers with parts piled on top. So we'll get to the important part. Well, the other important part, the Cybercab itself. But what I want you to get a feel of is what it's like to work in a Musk company, because I have some experience in that. It's like shipping containers in the parking lot with repurposed scrap under tires packed on top because you work anywhere there's room, because your project was defined today by you and the people working around you. Whereas if when I'm consulting with Scania, like I am now, or the Volkswagen Group, like I am now, or some Chinese manufacturers, things are planned years in advance. And if you discover something today, it will be years before you might have permission to spend money to find out if it would work. Here in a Musk company, this is what it looks like when you can change what budget is spent on in less than 24 hours, and actually many times less than 45 minutes. So you want a flexible landscape. You want your own crash center. You want to be able to queue up different things to crash in it and get it analyzed same day, things you didn't know yesterday. And you want to stack different stuff on top of those shipping containers. And now what you don't see here, which I'm I saw a lot of and experienced a lot of in California is tarps and sunshades from people working, actually doing design work on laptop, fabrication work with tools in the parking lots. So I'm assuming those were just stuffed in the shipping containers and this drone flight was taken between shifts. So very likely parts of that car were changed for more prototypes just before and just after. Um, so the general landscape is completely different than any of the world's major automotive manufacturers, including BYD in China, and especially including the legacy manufacturers like Ford or GM or any of the European manufacturers. Now, if we're talking about the Cybercab itself, Joe Tegmeyer already made some phenomenal analyses. So when we race Teslas in Japan on Fuji Speedway or Tsukuba Circuit, or in Europe on the Nürburgring, where I participate in track days and tourist driving, you want to add additional bracing from side to side, all around the wheels, especially, so that the car flexes the least amount as it's twisting and turning high speed around the circuit. Then in this picture, you don't see it, but Franz talked about it. You want deep, we call them bolsters on the seats to hold the occupants, especially the driver, but all occupants, in place as you're cornering very hard, as you're experiencing lateral G's and actually acceleration and braking events on the racetrack. And deeper and deeper and deeper is better. So when we race in Japan, many of our Japanese drivers prefer to also add 4-point harnesses to pull them further back into the seats. Well, the Cybercab is very intentionally the opposite of that. The best part is no part.
The seats are not really designed with bolsters. This isn't a driver's car. This is a car that's just going to get you comfortably from A to B. They're designed more to be like a couch where you get in, you can kind of slide into a really comfortable position and just enjoy the ride and in total comfort.
So we don't have a metal bar bolted on top connecting from the top of each front suspension to the other. It's often called a front strut bar, like you would see in a current Model 3, Model Y, or the just discontinued S or X. So if you're not trying to have the thrill ride of racing on the track, which in an autonomous vehicle, that's not currently the goal. That's not currently the goal of the Cybercab. The best part is no part. So anything that my race team wants to add for the Nürburgring or circuits in Japan, like deeper side bolsters, thicker, tighter seatbelt straps, and more strut bars around the suspension, more chassis bracing around the suspension, are all opportunities to be removed for the Cybercab. And that's exactly what we've seen. Franz was very specific about the side bolsters, but in this under the hood shot, you can finally see that also the chassis bracing has been intentionally deleted, not even removed. It was not designed for the Cybercab, where every gram could be saved.
What were you saying about the deleted part of the chassis?
Oh, fantastic, Alejandro. Now, a lot of people might recognize this. I'll point it out here too. If we look between the front wheels, and one way to tell where those are, not everyone here looks under hood of cars all the time. You can see on the picture on the left on our 2025 Model 3, the previous generation Model 3, you can see two round holes on each side with three bolts next to each one. Yeah, that's a
Okay,
strut
yes.
tower. That's one of the words we would use, a strut tower. So the shocks and springs bolt under that, and those then go down to the suspension. So when you're racing or doing spirited driving or the things that I love to do in a Model 3 or a Y or an S or an X, those you want them to stay in place relative to each other as much as possible for wheel control to keep the wheels where you think they should go as they're bouncing around on the racetracks. So It's easier to see looking at the orange electric cabling. There's a bar going between the two strut towers. For those of us watching, it's maybe easier to notice the black bar by looking at the orange cabling that's
Yeah.
threaded across the black bar. The purpose of that, um, everything's multi-purpose in a Tesla. They're the best in the world at saving grams. So it's also used to carry the wire across as a wiring harness holder. But the main reason that's made of a thicker, more expensive material, metal, is to brace the chassis, to make even less twisting. There's already almost none. The cars are so strong, but it's to make even less twisting. Now, if you're not racing, it has no value. So you'd find another cheaper, lighter way to hold your wire or actually try to remove that wire entirely, which is what they've done in the Cybercab on the right.
There's this other view from Tenet that I think it shows what you were saying, right? This part
Yeah,
here.
there's air between the front
Okay.
strut towers.
Okay. Okay.
Um, Now, just behind it, you actually have the casting.
Yes.
The
Okay.
Tesla's are already so stiff, so rigid, so
Yes.
perfectly engineered, so strong. What you'd want to do for crash safety is have this really rigid box that the humans are inside and then really soft stuff around it.
Okay.
And one of the soft things can be suspension parts. I mean, they're not soft at all, but relative to this incredibly rigid survival cell, they can be a little bit softer. So in the event of an impact, they smush flat, absorbing a lot of energy against the really strong survival cell. And one way to do that is to put the suspension made out of slightly softer metal that's braced in front of the survival cell, which is why the front wheels are usually quite a bit in front, and definitely in front of the feet of the occupants in most cars. Well, in the Cybercab, they've made that survival cell casting a little further forward to make the car even more compact, but it is still behind the front strut towers, the suspension, the front wheels, and they haven't braced them. There's air between the two. So the best part is no part. The car is being deleted to have the fewest parts possible. I've not seen a part count for the Cybercab yet, but I think we'll all be very happy. It's probably way less than a typical 10,000 part count for a vehicle of that size.
Think that at some point Elon Musk, and I don't know if it's Lars Moravit, they said that it has fewer than 50% of the Model 3 parts.
Cut the part count of Cybercab down by a substantial margin. We're going to be delivering a car that has roughly half the parts of Model 3 today.
And the big washer fluid reservoir, many people are saying, okay, it's so huge in comparison to the Model 3, Model Y that now is here in the front part of the hood, that the main reason is for the cameras, for washing them. But do you think that there's any other reason for this huge bottle?
These are data centers on wheels. These are compute centers. And when we look at the thermal management of a data center, we have these massive, relative to the size of the wafers inside, coolant lines for thermal inertia to keep the heat balanced. Now, when you look at the Model 3 on the left, you run into the primary limiter that I have racing Teslas, and that's all the current EVs, Teslas included, can race for about 30 minutes before overheating, before the battery pack, the thermal inertia in the battery pack gets hot enough that the car loses enough power that it's no longer racing, it's crawling. And before the cars run out of charge, the batteries become heat saturated. You never run into that, not on the racetrack, not on the Autobahn, no matter how fast I've driven these cars across Germany, sustained pace, they're fine at dissipating heat. But on the racetrack, the heat builds up. And no other electric automaker has conquered that yet. So when we're racing these cars, we're looking at the cooling system, the radiators, we're trying thicker diameter pipes to move coolant around. We're trying additional radiators, larger radiators, more air ducting through the radiators. But it's not the cooling system that's the limiting factor. It's the passage of the cooling fluid through the battery pack. So unless we split the battery pack open and change the cooling channels inside it, we're not able to have significantly difference in how long the cars can race before the battery packs become thermally saturated, before they become too warm, and then they need to cool down for about 45 minutes before we can take more laps. So you'd expect the best part is no part that the cooling system would be way thinner, way smaller on the Cybercab, but it's not. It's way bigger. And that's not just washer fluid is my working theory, is that's doing multi-duty like Tesla is always experimenting with. It's also circulating through parts of the battery pack and parts of the electronics. So why? It's a data center. When this car is not being called for taxi duty, or even when it is, but it's not using 100% or 80% of its available processor bandwidth, it's very likely going to be doing as much useful compute as possible. And when you think of data center architecture, it's exactly this. A data center is like a race car full of silicon wafers instead of batteries and electric motors. So you'd expect when the opposite of racing is happening, the Cybercab, you would have the least cooling. The fact that there's this enormous bottle here makes us think very likely it's being engineered as a data center on wheels from even these prototypes, even these crash testing rounds. And very likely, just as the Starship continues to get bigger and Tesla's data centers, XI's data centers continue to get larger, very likely that bottle will get even larger. That to me looks like a prototype. Its geometric corners are exactly the kind of shape that we would fabricate same day with tools in those shipping containers in the parking lot with our hands, not waiting on external suppliers. As that shape gets volumetrically and flow optimized, it will likely become a more curvilinear shape to fill in as many gaps as possible. And as other modules around it get smaller and optimized, the coolant bottle, washing nozzle coolant bottle, will likely get larger and larger to fill in that gap and look less geometric and package in. So that same fluid that can be used to clean lenses, very likely, that's probably true, can also be used to balance temperature, to move temperature from one area to another. Most of the time it's to dissipate heat, but actually in certain weather scenarios, you use it to put heat where you want it to get in the optimum temperature range.
Great. And it makes a lot of sense with everything that Elon Musk has said about the all Tesla's vehicles being data centers for inference AI computing. And apart from that, do you know what these big four black pipes are here on the right picture of the Cybercab?
Some automakers, when they make prototypes, they change the color of even items under the hood to try to fool photographers, or they wrap them in different colors plastics. But Tesla doesn't usually worry about that. They're moving so fast, they're not worried about hiding. They're just worrying about pace of execution. So I'll assume these are the same colors that the production counterparts would likely be. And black tubes in production are either wrapped wiring looms, so lots and lots of wires inside, which I don't think is the case here. It doesn't have the texture of a loom wrap, or they're coolant tubes. So very likely these are different heat exchange coolant tubes and lots of them. You might expect one on each side in a race car, depending on your coolant setup, and cooling matters a lot. for racing. Here we see way more. So everything that's been learned in the octovalve is likely being used here. And my guess, my assertion, is it's again balancing coolant through even more compute capabilities and the battery pack, and not as concerned with balancing heat in the drivetrain, the
Yes.
motor, the electric motor.
Okay. In an article of not a Tesla app, this site, they have said that Tesla moved the climate control components from the behind the dashboard into the front bay. Do you see that assertion here?
There's enough, well, what we would want, like the engineering ideal is
Yes.
to have all the hot and cold generating stuff as close together as possible. So you don't have to move heat very far as you're heat exchanging. So the engineering ideal would be to have your hottest point and your coldest point as near each other as possible. So you have the shortest distance to try to mix them to manage the hot and cold of both. Because most of the systems in a car operate ideally, they have their most efficient operating range at around ambient temperature, around healthy human temperature. So you don't want really hot things and really cold things. You want to put really hot and really cold things as close together as possible so you can balance those temperatures. Then also the act of moving temperature back and forth has positive effects. You can gain energy back depending which way you're moving the temperature. So what you'd want is the coolant right on top of the motor, right next to the CPUs, and as near as possible to the batteries and the heat exchangers and your coolant pipes. That's what you'd wish. So ideally, these would all be here. And that's another good argument for this to try to be front wheel drive. Um, However, in a Cybercab, I don't think we're going to have as much heat build up in the motor. So even if the motor is all by itself in the back, I don't think that will have as much of a impact as it would in other Teslas that are driven by humans. Because a lot of the heat buildup comes from rapid acceleration and not from cruising or slow acceleration, like Joe mode or chill mode. So when we look here, I can't see the heat exchanger. I can't tell. It might be right
Okay.
here. Some other people might be able to circle it, and kudos to them. And when we have Tesla teardowns, come on, Titan, let's do it on the Cybercab when you can. We'll have definitive evidence. I can't see it, but what I can say is the coolant hoses that we do see, which is what I believe the black tubes that we just talked about are. That's exactly what they look like to me. The coolant tubes we do see are the right number and the right diameter to be going through the heat exchangers. So what we're probably seeing is the heat exchangers, the heating and cooling system, which is likely through the next evolution of the octovalve. It's probably more than eight. Um, Probably everything is centered right here, which is exactly how a data center looks.
Right here on the front, right? Where the four tubes end here, you mean?
That
Or
is likely the top of the radiator. The back
okay,
side of them, where it goes out of my view, is
yes.
likely the tops of the heat exchangers, which are likely doing multi-duty for the occupant temperature and chip cooling and battery cooling, and very likely motor cooling.
Okay, great. And apart from everything you've been speaking about, the missing crossbar beam, that the best part is no part, the huge bottle, all these tubes, and the heat exchanger, do you see something else that is different from what you're used to of the regular Teslas?
Well, the other picture you showed, the a little lower view, looking, here we go. It sure looks like we see a lot more raw aluminum casting, even than we see in the GigaCast Model Ys that are in customers' hands now. It looks like the raw castings are becoming the surface finish of the car in more and more places, which is what you want. when we're building any product, if the structural material, the thing that holds it together, is also the surface material, the thing the users touch and interact with
Sorry.
or see, the shiny silver part, yeah, that is likely the front of the casting, one of the castings. And in other Teslas, we're not seeing that's the very likely the firewall between the front of the occupant's knees and feet, giving them much more legroom and higher up legroom than you would have in a traditional car. You you can maybe see how the front of that casting goes up all the way to the hood line. So likely inside, you very likely don't have just a little pocket to put your toes like you would in the back seat of a taxi under the front seats, even a minivan taxi. Instead, you likely have room up to above your knees, above your knee height, giving a radically spacious first class feeling. Actually, beyond first class, a lot of first class seats also just have a pocket for your feet. Very likely. Then the best part is no part. There's also not cladding in front of it. There's not other material in front of it for noise absorption, etc. It's probably not needed because of channels, pockets, cooling lines that have been cast into that casting very likely. Now, it's also a prototype. So maybe there's sound deadening cladding and visual cladding that's not attached. But my guess is that's not the case. We're seeing more where the structural material is also the material you see and touch, which is the definition of the engineering ideal. The hard part is to make the structural part look good, sound good, and be comfortable to touch, not too hot, not too cold, which with all that heat management, probably even the firewall is not too hot or too cold, even on a 0 degrees Celsius day or a 40 degrees Celsius day.
Great. Now, Joe, if you agree, let's pass to the manufacturing part because there's one video that Tesla shared after the last shareholder meetings that I think is really interesting.
Let's start from the outside. That gold color is when I was a Tesla employee, the color that every Model S and Model X started as. We would dip the cars in protective underlayers that also helped seal them for water penetration. And all the cars are gold for a little while before different layers of paint are built up on top. And actually, I tried to order one of the first plaids with this to save weight for racing. Paint actually adds, actually, it's not a small amount of weight. And I thought it'd be cool and unique. But stopping the process to take one car out early before it's channeled through the rest of the line was possible, but no one wanted to do it, and I didn't want to bother anybody too much, so I let the idea go. I ended up buying a blue plaid that just went through the regular paint line, and then a black plaid that just went through the regular paint line.
And apart from the color part, in this first part of the clip, they show this sub-assembly joining with this front giga casting. Do you recall if that was like common or this is like an innovation for the unbox process?
Well, it's quite different. There's a front subframe in traditional manufacturing, and here the front, what would be thought of as a front subframe, has much more of the car in it. Part on the bottom is a lot bigger, and much wider and much longer than it has been in the past. And this giga casting is different in that it than previously, in that it's much more open. It's like a topper with a hollow bottom, which has been the goal for a long time. A toy car is very often made so it can be flower potted together or clamshelled together. And like a remote control car, very often the cool exterior that still looks like a cool race car is many times a single piece of Lexan or various plastic that sits on top. This is a lot closer to that than any car has ever been before. The front subassembly is usually much, much smaller, so that the frame, so that it can be lifted into the frame, but the frame isn't nearly as open. This casting is becoming much more the shape of the top of a remote control car or a die cast toy car. And as a result, that subassembly is much bigger. They're nearly the same size in that picture, where as the front subassembly, the front subframe before was maybe half that size, which is part of why it's difficult to have so many components in the same place, because the size of that module, of that collection of modules, can't be so big. So that front module is the lower one is about twice as big. Now, volumetrically, what does that mean? Four times, right? But about twice as big as what I recall when GigaCast was being introduced for the Model Y when I was an employee. Um, and the idea that that entire gigacasting can be set directly down on top while the bottom module is nearly the same size, that is an innovation too.
This part that the two side door trims are being mounted with the robots, is that also common in the regular assembly of cars?
It's common in a very different stage of production that traditional manufacturing calls body in white, where just the side panels are stamped and then marriaged together in a very similar looking step, but there's no electronics. It's before water sealing, caulking. It's before any suspension components are attached. It's one of the first things that happens to the car shape of the car, right? Right after panel stamping, panel cutting is then body in white. That this is happening after there's even one wire in the car is weird, totally unusual. The unbox process breaks the time dependency. Now, why is that important is actually the radical innovation. These can be done at the same time. In every car being made now, there's sequential steps. You have stamping, then body in white, then sealing for water penetration, and then different stages of paint. And you can have the interior package being assembled if you're an advanced, quick manufacturer, and then put some of that in as a unit. But very often it's not. Just your seats are ordered and the seats go in separately, really one at a time, like one puzzle piece at a time. What's happening here is wiring is able to be attached to some of these modules, um, plastic parts, cooling. I mean, it looks like we have probably the battery is in here already. Probably the electronics are already active and the car is already in factory mode. It's probably already communicating back with the robots, putting it together, probably. You have parallel processing instead of sequential processing, which is what the Unboxed process has always wished to do. And this video is showing that, at least in this video, the wish has come true already. That you don't have to wait to put in the electronics until after, for example, body in white. This body in white step happening here, after you can clearly see wiring, all the sub-assemblies look like they're present, is new. That is different. And the reason that's meaningful is the total manufacturing time. Also, then the speed to introduce a change are going to be very different. They're going to be much faster. And the rate at
And
which they're faster is how many parallel modules you have going on. And in the earlier diagrams of Unboxed process, we've seen we probably have an 8 times improvement in speed of manufacturing and then also speed to introduce a change compared to, well, currently everybody else. So if you look at a map, a floor plan of a factory, of a car factory, they're typically separated areas by operation. You have stamping, you have wiring, you have suspension subassembly. If it's electric, you have motor winding, etc. They're separated that way. The one of the many positive effects or breakthroughs of Unboxed process is you don't need just one wiring center anymore. You have left side of the car wiring and right side of the car wiring happening at the same time. And center module, center casting, front, rear, and center, and those are being combined, it looks like, wiring running at the same time. So that's a 3x output to 4x output just in your wiring attachments, which all would have been sequential for anyone else currently. And in typical automotive manufacturing, you put parts on and take them off again. And here we can't see the whole flow, but very likely those parts aren't ever going to need to come off.
and in the rest of the clip, do you see something else that is interesting from what we're speaking about, or any other thing?
Then there's a duct visible on the front and the back of this video. And that duct is in a different place and a different shape than I remember seeing it. That duct looks bigger than on my Plaid. And I might be wrong, and this is a video, and I could be being tricked or I could be making a mistake, but that duct looks larger than on my 1,000 horsepower Plaid. So again, that's a reason for me to guess that this is data center architecture applied to mobile for the first time.
To wrap up a little bit our conversation, like, why do you think this happened? This was like an early prototype of the Cybercab shown in Elon Musk, Walter Isaacson's biography, and this is the final one. Why do you think that they made it longer and with this shape?
Well, first, from an aerodynamics and a safety perspective, longer is always better. So you have these competing forces in physics. From aerodynamics and safety, you would want these cars to be infinitely long. Um, and from manufacturing and maneuverability, speed of changing direction, which, how to say that? I'm used to thinking about racing and maneuverability. I'd think speed of changing direction. But if it's really easy to change direction, that means it'll take less energy to change direction. So that's also about efficiency, even if we're only talking about a taxi. For speed of changing direction or efficiency of changing direction and production cost and operations cost, you'd want it as short as possible. So you have two competing forces. Okay, why in the first drawing does one win? Compactness is winning. So ease of turning, manufacturing cost, lowest energy use for changing direction. Why is that winning in the top one? And on the what we're seeing in the real world now, the current stage of these items, why is aerodynamics and even more rear crash safety winning, even though that will use more energy to change direction, and even though that will use more energy and weight to make the vehicle? I have a guess. I have a guess. And it's a cute guess, and I don't know if it's true. My guess is it's for crash safety of items in the back, and it's for pet transport.
Um,
Dog mode has been a Tesla early adoption compared to other automakers that still don't have that type of mode. And if you have your loved furry animal members of your family in the huge cargo area, it looks like they're going to have similar levels of crash protection, even if you were rear-ended at high speeds to the human sitting in the front. The other benefit of that is the highway cruise speed should be able to be much higher with the same energy use than the car at the top. So my guess is pet safety one. And the side benefit of that is highway speed cruising, Autobahn cruising, range went way up, even though production costs, um, according to the total limit, how much material is used, even though how much material is used would have increased. Now, also the rear wheel got a little longer. I think even more battery was stuffed in to allow even more time between um, charging.
Joe, do you have something else to add of what we have spoken about, or
I want to thank Joe Tegmeyer for letting us all learn, even when we're not currently employees. I'll make a strong recommendation again, and that's for everyone in the world to work in a Musk company, uh, at least for a while. Um, Try to do something really useful inside any of the Musk companies, no matter which one. I think it will change the way you look at the world and whatever you do next. And if you're preparing to work in a Musk company, or if you're running your own company, Alejandro, your book is the only book in the world that explains the business process, the project management, and the case study, the business case study of how Elon Musk runs companies. I used to have this huge shelf of business books. I recycled all of them, and the only business book I have now is The Musk Way that you wrote, because I don't need to reference any of the other books anymore. They've been completely replaced. So if you're interested in business, in project management, in the methods and philosophy to effectively manage or be an executive, there's only one book now. They've all been replaced, and it's your book. Everyone, please read it if you haven't already, and use that as part of your prep to apply for any Musk company and do as much value as you can. I can't imagine you regretting that decision if you did it. It would take a huge amount of courage, but I hope everyone considers it.
thank you very much for the praise. And I said it on my book that the book started because of our, I think, two or three first conversations that it's so inspiring to listen to you, like the way that Elon Musk creates his companies, that it made me think, okay, I have to research it even further. And it was so rewarding to write that book. So thank you for open for open me that window, the window of the Musk way. And I guess that everybody that is watching this video knows you, but maybe somebody that doesn't know you, where can they follow you?
Oh, I'm most active on X. I'm at Joe Justice on X. I am on Instagram, but that's more like food pictures. And um and Facebook is still connected to Instagram, so I put some family stuff on there sometimes. But I'm most active on X, even though it's more unfiltered and business aiming, more philosophy, more science, and more business. That's the best place to reach me as a person. For business stuff, you can reach me any of those places, but I'm most active at the Agile Business Institute as chair of the board. And that's EN for English, .abi-agile.com, or abi-agile.com takes you to the Japanese site, because I do live in Japan now and I fight hard to improve my Japanese skill every day. And wow, that is a challenge. Um, I don't release any of my photos from when I was a Tesla employee. I wait till Tesla does. But this one is so zoomed in that I don't think I'm gonna go to jail forever just for serving this one. So
Ah,
here
okay.
is
Yeah.
a Model X
Yes.
coming
Yeah. Yeah.
through.
Yeah.
And this is before paint.
Yes.
And they're all this same gold color. To me, it looks like the same. I mean,
Yeah,
chroma
it looks
key
really, really
really
similar.
changes.
Yeah.
Yeah. As every car before it enters paint is this color as it's dipped. Now you can see spray lines because they're dipped, but there's spray prep, or there was at that time, spray prep that makes it bond. And then
Yeah.
electrical current is put through the conductive materials that bond this really hard shell. It makes a shell.
Yeah.
It's electron plating of to the car. Now, the A pillars here for crash safety, I don't think those are plastic all the way through. And those were the same color gold, which makes me think this super durable um, enamel electron coating has been mixed in with the plastics, and then it's just being left on the metal parts, which I would assume is what the A-pillar is. And they're exposed. I don't think they have plastic cladding. I mean, here this part's clad, but these are exposed metal. I think the outside of the A-pillars, sorry, this picture is too low, but are the exposed part. There's not cladding over them, or there wasn't at that time. Yeah, we're just seeing deleted and deleted and deleted steps. So the castings, very likely those are going to be more and more the final part you see and touch of the cars as the temperature balance through the casting during use, through heating and cooling channels being cast into more and more and more cast in the castings. Likely, this is what the inner and outer surface of the car will finally look like instead of putting different panels on top of them.
Okay. Thank you very much for sharing. And let's hope you don't end up on jail. Otherwise, I'll go to visit you with some paella.
If they let you slide it under the jail bar.
Yeah, yeah,
Yeah,
yeah.
maybe a hacksaw hidden in the paella.
Yeah.
Alejandro, it's always my pleasure to learn from you, learn with you, and spend any time with you. I hope you have an amazing day. For everybody
It's
listening, I learned a huge amount getting to read Alejandro's writings and watch his videos and listen to his voice. And I hope you're enjoying it too. I'll see you
Thank
on
you very
X.
much. But before we end, I have a tradition in all my interviews that the interviewee, that you have been an expert, a veteran in my channel, has to say the same sentence that I say at the beginning. So it's, hola, soy Joe Justice y estoy aquí para que triunfes.
Hola, soy Joe Justice y está aquí para que, que triunfes.
Yes, yes. We got it. Okay, this was awesome, but how are they going to clean these cybercabs? I did an exclusive interview with Chinmay Patil, the lead engineer who built the self-cleaning robot of the Cybercab, and you have a video here. I really recommend you because it's amazing.